Welcome back to Math 124, Introduction to Statistics. Today we're going to be talking about hypothesis testing for a proportion. So, do you remember our buddy Z star that we got from just going to the normal distribution in StatKey? Well, you can forget about it, at least for now. Instead, I want you to remember way back at the beginning of the semester when we talked about Z-scores. And when we talked about Z-scores, we were looking at a data point, a value, and comparing it to the mean of the population to see what the difference between these two was, and then dividing by the standard deviation. We were getting a measurement of the distance our value was from the mean in terms of standard deviations. So we will kind of be returning to this concept. And as we're doing hypothesis testing, we're going to look at this as our sample statistic minus what we expect to be normal, our null parameter, over our standard error. When we are performing hypothesis tests for a proportion, this will look like our sample statistic, our sample proportion, minus the proportion we expect if nothing has changed, divided by our standard error. And because we are doing hypothesis testing, let's use Z sub 0, Z null, okay? But we do have a formula for the standard error, right? So let's go ahead and put that in as well. Our Z sub 0, or our Z null, will be the sample proportion minus the null proportion, what we expect, divided by, and this is where we change that standard error formula just a little bit, so we are always comparing against the null hypothesis, so this will always be our null proportion in 3 different places, here, here, and here. So big deal. We found Z null. So what are we supposed to do with this? Well, the cool thing is you're almost done when you have found Z null, because that is going to be your test statistic. That means after you have calculated Z null, after you have calculated your test statistic, then you're going to go to either a Z table or you are going to go to StatKey, take the StatKey option, and you're going to find your p-value. And then you can compare it to your significance level and state your conclusion. Let's do it with some actual numbers now. In an American Animal Hospital Association survey, 37% of respondents stated that they talked to their pets on the telephone. A veterinarian thought that was nuts. So he really did not think that many people talked to their pets. So he randomly selected 150 pet owners, so that's the size of the sample he selected. Obviously, they were probably from his practice, and discovered that 54 of them talked to their pet on the telephone. Now, does that veterinarian have the right to be skeptical that 37% of the population who have pets and a telephone talk to their pet on the telephone? My sister doesn't have a pet, so she talks to my dog on the telephone. Okay, this isn't earth-shattering, so we will use the usual level of significance. We'll use 0.05 level of significance. All right, so the null hypothesis is that the population proportion equals 0.37. 37% of people who have pets and a phone talk to them on the phone. Okay, and the alternative hypothesis? The veterinarian thinks that less than 37% of pet owners talk to their pet on the phone. But let's figure out the proportion in his sample who admitted that they talked to their pet on the phone. 54 out of 150? Well, that's a little bit lower. 0.36, 36%. So here's the key. We have to find the test statistic. There is our formula. Let's fill in the values that we have. Our sample proportion is 0.36. Our null value, or the proportion we expect if the null hypothesis is true, is 0.37. We divide that by the square root of the null proportion times 1 minus the null proportion, which would be 0.63. And then we divide that by the number in the sample, which was 150. And our answer is negative 0.254. So yes, the proportion in his practice is less than what we would expect if it were the null hypothesis, but is it significantly less? This is our test statistic. The way we're going to test it is to find out what p-value is associated with a z-score of 0.254. Now, you could go to a table of z-scores, but for this one part of calculating by formula, you can go to StatKey. All right, and in StatKey, I'm going to go to the theoretical distributions, to the normal distribution. Come on. Let's go to the normal distribution. We will be performing a left-tailed test because the vet thought that the proportion would be lower than what had been previously reported. Now we need to change the cutoff value. The cutoff has to match our test value, and that is negative 0.254. Hit OK, and there's our p-value. The area to the left of our cutoff value, our test value of negative 0.254 is 0.400, fully 4/10, 40% of the area under that curve is less than that value. Now, the important thing though is how does that p-value compare to our level of significance? Which one is smaller? The level of significance. The alpha wins. We do not reject the null hypothesis. So yes, people do love their animals that much. Or, to answer this formally, there is not enough evidence at the alpha equals 0.05 level of significance to say that less than 37% of pet owners talk to their pet on the phone. Here are the steps that I used and that we will continue to use to perform hypothesis tests. First, we will formulate the hypotheses using the correct notation. Yes, I'm referring to H sub 0 for H null and H sub A for the alternative hypothesis. But most importantly, you must realize you are inferring either a population mean or a population proportion. So use the correct notation, a mu for the population mean, or as in these examples, p for the population proportion. You will then calculate the test statistic using the correct formula. Now, for communication and especially for grading purposes in our class, please show the formula you are using and the substitutions you made. We then use StatKey to find the p-value, although you can use z-tables or t-tables to find the p-values, but it's more complicated than the way we're doing it. I will include a link at the end of the video to a video that I did for a previous iteration of my stats class, so you can see how that works. And the fourth step is to compare the p-value to the significance level to both form and then write your conclusion, be it informal or formal. Okay, here is one last example. A headline read, "More than half of Americans say federal taxes too high." The headline was based on a random sample of 1,026 adult Americans, 534 of whom said taxes are too high. Okay, taxes are important, maybe not as important as health. So let's give this I don't know, a 0.02 level of significance. So would that be an accurate headline? Let's find out. First, we should establish our null and our alternative hypotheses. The headline is claiming more than half of Americans say the taxes are too high, so our null hypothesis should be that half of Americans think taxes are too high. The alternative hypothesis should be P is greater than 0.5. Let's start our calculations. First, we need to find the sample proportion. So P hat will equal 534 divided by 1026, and that equals 0.520 if we round out to the thousandths place. And now we can calculate our test value. Z equals, remember we're going to take the sample proportion, subtract from it the proportion we expect with the null hypothesis, P sub 0. We're going to take the square root in the denominator of P sub 0 minus 1, or times 1 minus P sub 0, divided by the number in our sample. Let's plug the values in. And there they all are in the correct places. Let me say one thing about you're putting this into the calculator. Make sure that when you are calculating your Z null, that you put parentheses around what is in the numerator. Either that or you'll have to do the subtraction in the numerator, hit enter, and then do everything else. But if you want to put everything in at once in the calculator, you can do it this way. Make sure you close the parenthesis because that shows you what is underneath that square root. And now we have that our test value, our Z sub 0, equals 1.281. And we can go to stat key. Now, as you can see here, I have gone to stat key's theoretical distributions and I have chosen the normal distribution because the headline read more than half of Americans. I'm going to do a right-tailed test. And then I have changed the cutoff. It was originally set at 1.310, but I am changing it to our test value of 1.281. I hit OK. And here are the results in stat key. Our p-value for our test value is 0.100. Let's return to our problem. So let's compare. Here is our level of significance. What was our p-value? Our p-value was 0.100. Which one of those is bigger? Clearly the p-value is bigger, so we do not reject our null hypothesis. Okay, remember our p-value has to be less than our level of significance. Because it is not, we do not reject our null hypothesis. Well, does it mean that we accept the null hypothesis and 50% of Americans think taxes are too high? No. We never accept the null hypothesis. But we can say there is not enough evidence to say that more than half of Americans think federal taxes are too high. And that concludes this video. The one thing you want to remember is never accept the null hypothesis. Either reject it or do not reject it. Do not accept it.